Welcome. In this video, we are going to find the first and second derivatives of a curve defined parametrically. Namely, we're given that the x values are a function of t, that is, the x values of this curve are t squared, and the y values are given by e to the t. So for the first derivative, that is dy over dx, this means we need to take the derivative of y with respect to t and divide that by the derivative of x with respect to t. So let's take care of these. So dy over dt of e to the t so d over dt e to the t divided by the derivative with respect to t of t squared. In our numerator, we have e to the t since e is its own derivative, and in our denominator, we have 2t. Next, let's find the second derivative. So for the second derivative, we need to take the derivative of the first derivative with respect to t. So this becomes d over dt So for our second derivative, so for our second derivative, we need to start by taking the derivative with respect to t of our first derivative and divide that by the derivative with respect to t of the x component. So on top, I have the derivative with respect to t of e to the t divided by 2t, and on the bottom, I'm just going to type or write in the 2t, and on the denominator, we have just 2t, and that is again because the derivative of the x component with respect to t is 2t. So let's take care of the numerator separately. So let's do that over here on the side. So here on the side, we're finding the derivative with respect to t of e to the t divided by 2t. This is just a straightforward application of the quotient rule. So that is, I need the derivative of the numerator times 2t minus the numerator times the derivative of the denominator divided by the square of the denominator. So this is 2t e to the t minus 2e to the t divided by 2t quantity squared. Now let's go ahead and replace this here in the numerator. So now in my numerator, I'm going to write this derivative we found here. So there is this same derivative, just simplified a little differently. I factored out the common terms, and I'm purposely not multiplying anything yet, so you'll see why in a second. And then this whole quantity is divided by 2t. So this is 2e to the t times t minus 1 divided by 2t quantity squared times 1 over 2t. I have matching factors in the numerator and denominator. So finally, I end up with the second derivative of this parametrically defined curve is e to the t times t minus 1 divided by 4t cubed. So to recap, given this parametrically defined curve, here is the first derivative, and here is the second derivative.